question in the Q&A, and I will go ahead and answer that. So yeah, it has to do with just like becoming a creative coder and that path. And I think I have enough time to mention that, talk about that quickly. So I think like if you're interested in really like this can be applied to anything, but what really got me to where I am now was starting a daily practice where I really held myself to creating something and posting it every day. And I used Instagram as the way to do that, but it doesn't really matter what platform you use. I think the point is that you do it every day, and also sharing it every day is a nice way of holding yourself accountable. But it doesn't have to necessarily be coding. It could be, I think if you're a musician or you play a sport or really anything, this is like something that can be applied, and it doesn't really matter where you are in your process. You should, starting it, you'll be able to immediately start to see the sort of progress that you make and track it over time. So I think that would be the one thing I would say is really key. Certainly more that can be said, but I want to go ahead and kind of get going on this last example, and then if there's more time at the end, I can certainly take more questions. So I'm going to go ahead. This is the all examples group. So this last example here, I'm going to try to tackle this over the next, the last portion. Definitely, I think racked my brain the most out of these, getting this one happening. I'm like, was inspired originally, I'll kind of zoom back to by Sean Zelmer. So this is Sean Zelmer's work. And specifically, I really liked this cube that like bursts into miniature cubes. And I was like, okay, how do I do that in TouchDesigner? So a lot of my kind of inspiration comes from like seeing other people in the field or other people doing work and like saying like, that's cool, how do I do that? So, some of my own, like eventually I kind of created this is actually in reverse, but kind of the same idea. But then I also said, okay, well, like as I expanded it, I eventually came across this idea of like the nested cube, and it can be applied to other shapes too. So we're going to go ahead and look at how we can do this kind of looping example. So I'll go ahead and start from scratch, and we can take a look. It will use a lot of these same techniques. One thing we need to do, actually, so you should have in the examples, I'm actually going to pull this over here. There's the phaser chop folder if you've downloaded it, and that is something that you'll want to install for this example. There is, if you go to the nested boxes, a version that does not use the phaser chop. The phaser chop, I should say, is a custom operator created by David Braun, and he has a great talk on it called Quantitative Easing from the last TouchDesigner Summit if you want like more information. But I will be using it in this example. The native version only uses native operators to TouchDesigner, and it actually looks very similar. Like we can kind of achieve almost the same effect. Really subtly different as to like how it's controlled. So you could take a look at that too, especially if you don't have the phaser chop installed, or if you're not able to. But what we can do is, if you go into this phaser chop, there is both the DLL for Windows users, and then this phaser plugin that Yasushi actually compiled for Mac. So we're not sure, it was on an older Mac, so we're not 100% sure about compatibility for the Mac version. We haven't really been able to test it a whole lot. So you can try this if you're on Mac. What you do is you will copy it, either the DLL or the Mac version, and you're going to want to navigate to your documents, and then derivative, and then plugins. It might be a slightly different path for the Mac system. Thanks, Yasushi is giving these great links over here, perfect to the talk and in the chat. And then you'll want to paste the DLL into your plugins folder, or the vice versa for the Mac. So go ahead and try to install that. You might need to reopen TouchDesigner. I'm not sure for it to recognize, but it'll probably give you a little pop-up telling you you have a new operator and making you confirm that it's okay. So go ahead and do that, and I'm going to get started on this example. Okay, so we have our fresh TouchDesigner window here. Delete the existing operators. So for this, we're going to start with, it's like a nested box, but I don't want the interior of the box. So I'm going to first do that in SOPs. I'm going to create a box SOP here, and I'm going to hit A and then W to view as a wireframe in the operator, and hit P for my parameters. So this is what I'll use initially, and I want there to be divisions. So I'll click this. This is, I'm going to draw cubes at these points. So this is going to generate my initial positions. I also want to create a constant here. So this is going to be my parameters, PARS. I'll just call this scale. It really has to do with the number of like rows and columns and so forth, but this is what it'll be. So I'll set this to 7, and I want there to be basically 7 points along each edge. So if I drag, open up the viewer here, and drag this onto divisions, if I actually drop it onto the name, this is a nice shortcut for exporting to all 3 parameters. So if I drop it on here, click chop reference, you'll see that it automatically exported it to each. And in this case, I actually don't want this to be the same, because if you look and count, this is the number of divisions, but we actually then get 1, 2, 3, 4, 5, 6, 7, 8 points. And we actually want this to be 7 points just to keep things straight. So, I'm going to do -1 for each of these. And now we've got 6 points along each, because we're counting the corners in this case. The next thing we want to do is delete the points that aren't the very outside of this box. So all of the internal points we don't want, because this is kind of like a nested effect. We want there to be another box inside of it that closes around it. So I'm going to add a group SOP. So this is a way that we can select things like points and primitives. And I'll choose points. And then under create, I'm going to use a bounding box. So I'm going to click bounds, choose the bounding box. And in this case, I'm going to just type in 0.98 here, so that I'm going to be selecting, you can see in this viewer, the red box is showing us basically like what the bounding box is. And actually, if we go back to group, there's probably a way to do this without toggling this, but if I go back to points, you can see that the yellow ones are what I'm selecting. So essentially, I'm keeping the outside and then selecting the internal points. Now, the next step is we want to delete the points on the inside. So I'll create a delete SOP, and currently we need to do 2 things. One is that in our group, we have group 1, so I want to choose group 1 to delete, and I want to delete selected points. So I'll choose points, and nothing changes because we haven't really, all we've done is remove the points. So if we look at our viewer and go to our display options and choose the points option, you can see, it's a little bit hard to see, but some of these internal points are actually being deleted. So it doesn't initially look like it, but they are being deleted. So so now that's great. We've got ourselves our outside edges essentially. We'll make a null and convert this to a chop data. So we're going to still do our kind of work in chops, but this is like, it's very common for me to generate my point data in SOPs if I have a way to do it. Especially grids are handy that way. So I've got my SOP to chop. I'll call this box null just because I might reference that later. And Yes. And then now we should go ahead and get a like instancing network, like our render network going, just so that we can see what's going on. I like to get that going as soon as possible. Yes, so we need, in this case, we're using boxes again. And I'll plug that into a geo. So this one needs to be made smaller. And so in this case, we can use our scale because we know that this is, you know, 1 is the width of this box. And we have 6 of them that need to fit. So essentially, or rather 7. So, you know, you might start by, and this is how I started initially. I, you know, dragged my scale over here, chop reference, and then I say, okay, 1 divided by the scale. So that, you know, we have 7 boxes, and so they should be 1/7, right? We'll look in a moment why that doesn't work, because, and you'll see, we'll adjust that slightly. But yeah, I'll try to keep it along the lines of the way that my my head went when I made this. So now we need a camera, yes, and a render. So pretty much the things you almost always need. Change this to 1080 by 1080. Adding a null. Cool. Adding the background. I'm just repeating myself now, right? Dragging this over. Okay, and then changing this to a top viewer and view display, hide the backdrop tops. Okay, so now you can see what's going on in our render. I'll also add a constant and drop that onto our geo. I'm going to call this color for now. Might rename it later. And then also, this effect had the same effect as our last one, where I will want there to be a wireframe version to give us sort of an edge look. So I will copy this constant, make it black. We'll change the colors later, but for now this will work. Under the common page, under wireframe, topology wireframe, and drag that onto our wireframe example, or our wireframe comp. Still going to be hard to see, but this will eventually let us get a little bit, you know, see the divisions a little better. Cool. And then next, let's actually instance this as a cube. So let's see what it's looking like right now. Under the instance, making sure I'm selecting both of these, turn it on, drop our, I'm going to rename this instances. Drop this onto our default instance operator and do tx, ty to z. So we've got ourselves the start of a cube, and and then I'm going to do a null comp, just because I want this to look at it at a slightly different angle. So we're going to do the same thing with our null, where we look at it. And I'll constrain this too. Eventually we're going to rotate it, maybe if we have time. So constraining it will let us kind of rotate our cube, our camera. So let's see. But for now, let's just kind of reposition this so that we can see all of the different faces. Actually, 1, 2, 2. Cool. So you'll notice that there's like spacing between these. We probably want this to be solid, and really what's happening here is we're drawing cubes at the points, which means that it's going to extend off the side of our box. But if we look at this box, each of these is actually, this is how we want it to look, right? With 6 boxes just like side by side. And so the width of these boxes, these internal divisions, is 1/6, 1/6, right? And so that's actually just our scale minus 1. So there's that extra padding that happens when it's spaced at the corner, which we can do in our expression by just adding a parenthesis here and doing -1, and then I'm going to copy this just for the speed, and there we go. So now we've lined up our boxes well. We can go ahead and maybe, if you want to see a little bit more of the wireframe, I didn't do this in the last example because we kind of ran low on time, but you could add a transform before the color and just like bring this uniform scale to like 0.99, and you'll see that the wireframe pops a little more. So that's something you can do to get that look a little better. So, okay, now we've got our nested cube. Let's see if we can actually get this happening quickly, because this is a complicated one. We need, again, we're going to want sort of our same timeline, because this is looping on the timeline. So frame and end. I'm going to grab a math and divide. Put this into a null. Again, because we'll probably want this later, trim. So that way we're kind of making sure it starts at 0. And I'll call this ramp. Cool. And then we're also going to use something similar to our previous. Well, we are going to use our noise chop again. So this is going to be essentially like, I want the outer, we're going to create like 2 sets of these cubes really. One that kind of flies in and makes this center cube, and another one that just like is the center cube and gets smaller. I have ideas for how to make this better now, where it's all one system that's just like phasing itself. But this is how I did it the first time, so it could be made better. But you can always make things better. So so here's our noise chop, and I want this to be set so that it is the same length as our SOP2. So I will go ahead and do that in the channel under samples. We could do this from the SOP2, but I'm going to do it from the chop still. I think that the other example pulls it from the number of points, just for reference. So SOP2 1.num samples. And then -1, because we want, again, the 0 indexing, we need it to be the same length. I'm also going to rearrange this again, so it's first 0.5 and 0.5, so it's going from 0 to 1, which makes our job a little bit easier. And then using our math, let's say, go from 1 to 10. So the reason I'm doing this is I want to take our instances here and kind of have them out in the middle of space and then pull in and kind of be lined up in this exact formation. So what I can do is multiply them by this noise. So I'm going to create a math, combine the chops by multiplying them. If we look at this now, they're like all over the place, right? But if we just temporarily, you don't have to make this one, but sort of multiplied this, scaled it, you can see, oh, okay, as we multiply this by our noise, because I've ranged it to 1, it's eventually going to reach the original location. So I'm kind of like pushing it randomly out with this noise. So this is what we're going to use to have it kind of like pull in for this animation. So I'll leave it here for the moment. This is actually going to be our outside box. So I'm going to rename this now outside, and I'll rename color. Call this outside color and outside wireframe. So eventually we'll make an inside version. But for now, get this first version working. So let's see. The next thing we want to do, we've got our timeline, so that's great, is we can introduce the phaser chop. So if we just like, you notice when we dragged that math, everything kind of came in at the same time. And that's cool. It's like an effect, but we might want it so that, like in the example, it starts at the bottom and then works its way up to the top as they're kind of piecing in. It feels a little more like it's building the box as opposed to just like fitting into place. And that's something we can do with the sorry, I got distracted. That's what we can do with the phaser chop. So what the phaser chop does is it takes I'm going to pull it from the custom tab. So that's where your custom operators will show up. And we want to give it, for the first input, we're going to give it like a shape, essentially like a pattern that's going to determine basically like the order at which they reach their destination value. I think if you watch David Braun's talk, he probably describes it more eloquently, but it'll make more sense when we actually see it in practice. So in this case, I want, the channels to the left, the higher this value is, the sooner it will actually kind of reach its destination. And then if we feed it the ramp, it's kind of moving backwards here. We might want to flip things around a little bit, but oh, I know. Yeah, I will do that in a moment. But yeah, you can see that we're driving it all with one ramp, which is our timeline. But the higher this value, the sooner it will actually reach, go from 0 to 1. And if we then multiply our noise by this value, okay, get some, oh, I need to set the length, don't I? So this pattern also needs to be set to the same number of samples here. Okay, so good. This one, notice that this one does not have the -1. So until you get used to it, it's a little confusing. This is the length as opposed to the range, right? 0 to 217. So that can be a little bit confusing, but something to note on the pattern chop. And then for this math, we're going to multiply these chops. So it's kind of slow right now, and I'm actually going to increase the this start. So let's do 200 or so. We can see it a little bit faster. Right now it's bursting outward, right? And so another thing we might want to do is sort of reverse it, because the example we had was pulling in. So I'm going to go ahead at our ramp, create another math, and range this from 0 to 1, or flip the range. So 0 to 1 goes to 1 to 0. So now we can see that it's kind of pulling in, kind of into shape. And one other thing I'll do while we're kind of working on this is, we could move the camera, but I kind of want this to build up from the bottom. So I'm going to basically sort my points here, which will give me essentially can help me define the order that this happens. So if I sort it based on the Y, you'll see that it goes in the Y-axis. I could choose random, for instance, and they pull in randomly, or other ways, but I'm going to use the Y-axis just so that it builds up from the bottom. And that's pretty much the only other piece we need is actually the scale, because I'll do that before we add our inside one, is so that it starts at 0, and then over time each sort of box grows into shape. So let's go ahead and do that again with the phaser system here. So I'll copy these same 3 operators. This pattern, I'm actually going to grab an S curve instead, and I'll copy the length. So this is for our scale. I'll even name it scale. So we have that. And this will give us just a little bit more of a curve, like an ease when it's coming in. Now, if we just plug this into our instances, so I'll go ahead and do that. And selecting both of these give us our scale. Something happened. What just happened? I'm must have deleted something. Hold on. Let's try this again. Oh, I plugged it into a math. There wasn't a merge. I'm sorry, it's getting a little late. So I'm going to add a merge here and bring the scale into that. So now we've got tx, ty, tz, and scale. And selecting both of these, let's add our scale. Now, you'll notice that it's like backwards right now in a few different ways. So we're going to have to go back to our kind of like things over here. So one thing is that we want this is our like destination value, right? So we're actually going from 1 to 0 for our scale, right? At the end, we actually want it to be 1. So we'll flip that. So going from 0 to 1, let's go 1 to 0. I know that we flip it up here as well, but this is helpful in certain ways that we might get to later. So now it is going growing, right? And then the other thing is that it's actually growing top to bottom instead of bottom to top. So we can do that by fix that by flipping the S curve. So now, all right. So now we're growing kind of like close to what we had as the animation. Now, one other parameter, the only parameter on our phaser chop is the edge, which essentially kind of determines whether, like how in phase the transition is. So if we bring the edge down, you'll see that like now the movement is, they kind of move more individually to their destination, whereas if we bring this up to 2, it all kind of moves in at the same time, closer to if you just had one value that was moving up. So we might make this 0.4. We can always change this later, and the edge, something like 0.5 for the scale. So things are kind of like floating in. Actually, maybe this can be 0.8. But again, you can tweak this as you like. It's just a way of refining like the way that all the pieces phase and move together. But cool, this is our like outside of the box, right? So the next step is we need to make it so that when it reaches this point, it then shrinks inside of itself, right? And we have, so the way I came up, like found to do this initially was to just create 2 instances, like 2 boxes, one that starts kind of moving in and then reaches this point right here, and then a second that starts there and gets smaller. So that there's kind of a seamless transition between the 2 sets. So there's an outside set and an inside set. And that way we can see them both at the same time, right? So if we look at this example, there's really 2 boxes, one that encases the other one. So to do that, we do need another kind of set of these comps. So I'm going to go ahead and copy these 2 and rename them. Oops. So I'll call this inside color, inside wireframe, keep things straight. And also, we're going to need its own instance null as well. So this one's called outside, and here is our inside, which I will match to selecting both of these. Now, we don't need this one necessarily to scale in the same, so we don't need our scale because it's always going to stay locked together. So for this, we will, our inside, I'm going to delete scale. Now you can see that it actually just, maybe it disappeared. I don't know where it went, but it'll be back. Let's see. Cool. So we also just want this to have, we don't need the scale option there. I see, so it's also, we don't want it to be flying in, so we always should select the original box data, right? So now it's in the way at the moment, but you know, it's in its original form. So the next thing we want to do is we can actually transform this entire system using the geometry comps, the uniform scale. And what we can do is we can use this same ramp to bring one of them down from, say, twice the size to 1, and then the other one can start at 1 and get smaller so they always meet at one unified point, which is where they kind of, let's like almost like a handoff. And so in this case, let's use our ramp, and I'm going to grab just the branch off from this and create a math and a null, copy and paste that. So this first one is going to be my kind of like outside scale, and this next one is going to be the inside scale. So for the outside scale, we will want to go from, I think, sorry, let's see, 1 to 2. So it starts, or maybe no, that might need to go to 2 to 1, but we'll see. And then the next one should go from 0.7 to 1. So let's see. Actually, no, it does want to go from 2 to 1, right? So, oh, it's counting down. I'm sorry. So we'll see how this works. But essentially, they should end in the same spot. Okay. So at the outside scale, we're going to, for both of these, open up the viewport, selecting drop this onto uniform scale. Okay, so now, oh yeah, so we can see that the outside one is sort of shrinking, right? So then eventually that box is getting a little bit smaller. And then the second one, we'll select the inside color and inside wireframe and drop this onto uniform scale here. Oh yeah, perfect. So cool. So we actually have the effect working, right? They're both 1 at the same time briefly, right at the end and the beginning. And then, or actually, no, they're not, never both 1, but there is a handoff that happens. So cool. So yeah, that's the essentially like the illusion effect where it kind of like comes in on itself. The other pieces that we've got in this is color. And so we can quickly get that going. Again, using, in this case, a noise. We're going to use a noise top. We could use a chop, but in this case, I used this one. Just there's different ways to go about it. And I'm going to grab the number of samples here again for the resolution, for the width. And I'll use random for the type. So this is going to be my color values. And if I plug this into a lookup, and then use a ramp, then I can use this to create a chunk of random color values. Let's see. So let's do something simple for the moment. And actually, here's a good example of how we could even be mixing types of operators if we wanted to in our instancing. I don't know if I do this in the example, but if we wanted this to be our color for the instance, the outside, so we call this outside color. Probably gonna, yeah, and then drag that onto. If we go to our outside comps, instance 2. We can drag our outside color top here. So now we're using tops and chops, and type RGB. And now we've got colors for the outside. It doesn't quite, it doesn't pop over quite yet. But in the example I did, the inside actually kind of like starts to fade once it's formed into another color. So that we can actually do that also in tops. If I just copy this right here, and maybe this one is, we could actually make it like a faded version or a darker, kind of like it's getting a little bit dull as it forms. You can always tweak this a little bit to your liking. Okay, so now we've got another set that I'm going to grab the same noise for. And so this is our kind of like target color for the inside. I'll drag that onto our instance 2. Select them both, yes. And then kind of what we need to do now is make it so that our inside fades between these two over the course of the animation. So I'll select my ramp. Actually have it right here. I can copy this, create a null, and I can use a cross top, which is just going to blend between the two. Because we're counting down, I'll actually make the top input our dimmer input, and then multiply or just put this frame right in here, chop reference. Cool. Okay, so something is, oh, I didn't plug it in. Here we go. So now it'll start fading kind of once it starts kind of like, once it's formed. So that's essentially what we have. If we look at, just because we're close to the end here, some of like the different effects that are on this, I'll just dive in here and talk through it. So one thing I'm doing is I'm rotating the entire kind of like camera. And because this is constrained to this null, if I rotate this null 360 like we did in one of the other examples, we're going to go do a full rotation across the entire animation. Now you'll notice that this one is set to 960, and we're actually doing 4 entire builds of this cube over the animation because I wanted the rotation to be slower than our actual like cube formation. So in this case, our camera is getting pulled from this initial ramp, but we're doing, again, some math where we're multiplying by 4 and then looping from 0 to 1, which gives us 4 smaller ramps inside the larger ramp. So that's essentially how we get the motion here. And then again, you can toggle on this ambient occlusion if you want to see some shadows. This also uses the radial blur component from the palette and bloom to kind of brighten it up a little bit. So you can take a look at some of those post effects that I have in the example. But that's essentially it for that example. So I see one Q&A, which I'm going to take a look at. And if there's other kind of questions for the last like 12 to 15 minutes, I can kind of field those. But yeah, thanks for watching. I hope this gave you some cool techniques to play with in TouchDesigner. And if you're, this actually question has to do with sort of, let's see, it's, is there a more or less ultimate recipe for implementing math formulas in TouchDesigner? And do you have any recommendations on where to start for someone who's not so experienced with TouchDesigner? So good question. I think like it depends on, like, I guess it depends on what math formulas you're talking about, because I think that there are a lot of ways to implement math formulas, especially like Python expressions, because you can type direct like formulas in that way. Or if you start getting into Python or know some Python, that's a good way that you can use scripting to bring in formulas. There are things like the script chop as well, which lets you get a little bit more into that. But a lot of it for me was just like figuring out how to conceptualize math formulas with these tools that it gives you. And that really, I would say, just takes a lot of time. So of like getting to know the language in the way that you would any sort of language. So I don't know, I hope that, you know, it can be intimidating, but also if you start kind of piece by piece, going through tutorials, exploring things, that would help get you started. So tips that bring down the computational expense for real-time performance. Sure, yeah, so, you know, some of these, it's like, you have to maybe compromise, say like, okay, am I gonna have screen space ambient occlusion if I have a lot of other things going on? That's a big one. For live, so there's certain operators and things that you do that take up, you can look and see how long things are cooking. So that's one indicator that helps to kind of see what's happening. Again, the I also use this quite a bit, the performance monitor. So if you're really trying to like get something running smoothly for performance and you analyze it, it'll actually tell you how long every single operator is taking in your entire network. So this is like really good for saying, okay, what's the biggest hang? Like what's taking the longest time? A couple other tools. There's a lot of optimization tools, but it's really what it comes down to is if you're balancing a lot of different networks, making sure that things are cooking when you're not looking at them. So if I am up here, like, and I am not looking at these operators, I don't want them to actually have any CPU cook time or GPU cook time. If they do, that means that there's some external source that's telling it to render, because you want to be able to content and stuff in the background that you're not, like if I'm not actually looking at this content in a performance, I want to be able to pull it up quickly but not see it. So a lot of those kinds of tiny details, it does take time understanding, you know, what operators might actually force something to cook, to find those little like optimizations, but that would be kind of like my quick response. And then I think it's like also learning the system building aspect of, okay, I have all of this content. How do I like, you know, switch between it in a live setting? And that's a whole nother workshop in and of itself, is to do that in a smooth way where you don't get hiccups or frame drops, and you keep a relatively high frames per second or FPS. So definitely a lot there. I don't know if that helps, but I think in a lot of this stuff, yeah, it's there's certain things too. A big one is avoid ever like animating in SOP world. That is definitely going to be heavy on the CPU, at least in the current state of TouchDesigner. So as much as you can do, work in chops, but even more than that, if you can work towards tops and GLSL and use the graphics card, that's like eventually where you might want to move if you're trying to get something that's really going to be, you know, running smoothly. So yeah. Other questions people have? I have, you know, a little more time. Oh, let's see. Rob has a question too, about also sort of transitioning different scenes for a longer piece with many scenes. And that's something that like I've worked on for a long time. Like I have a different, like a tool that I've probably rebuilt 7 or 8 times, but it depends a lot on the scenes. I think that like you want, like kind of an A/B switcher is often actually the solution. And then it's just, again, like getting things to run on the hardware that you're working with. And I usually try to work up to the hardware. So, you know, like I have some headroom, but I want it to still run smoothly. So I don't know, it's very case to case on some of the projects that I work on. Yeah, cool. Other thoughts or anything? Can't see. Cool. Well, if that's it, then yeah, thanks everybody. Hope. Oh, here's Ben Voigt. Okay, great. How long have you been using TouchDesigner? Really like have to do the math sometimes. I think that I really felt like I was using it a lot in like 2014 and 15. I was maybe exposed to it in 2013. So like I would say really seriously for like 5 or 6 years. And that was definitely in school, but no one taught it at University of Michigan, where I was in a music school, kind of like performing arts technology was the name of it, and it was sort of like music and technology and installation art, and pretty much kind of like what you want to do with it. No one taught it, so I had to sort of learn from friends who knew how to do it, and then like I basically had to find projects that I could use TouchDesigner to work on. So that's another suggestion, is like if you can find a project to use TouchDesigner for, and commit to doing something, like whether it's a performance or an installation, that can be a good way to like get yourself to, you know, get some put some work in. Cool. One is Rob says users who inspire your work and how they inspire you. Definitely like the folks who I mentioned today, Sean Zelmer and David White. I really love David Braun's work. And Paqueta 12 has like all sorts of crazy tutorials and examples. And yeah, there's definitely more. Zach Lieberman was like one of the reasons I started doing my daily sketching. He's an open frameworks person, so still super inspirational sometimes. I think like how to learn generative design in general, how to, good question as well. I think it, you know, for me, it's always like continuing to like research and look at what people are doing and being like really inquisitive about how to make things happen that you see, and just like reading lots of resources, you know, as much as possible, like kind of being a sponge and just doing it every day. I think that's a lot of it. Okay, well, there's a lot of more questions. Cool. So I hope that helps. It's just like a long process. Let's see, my GLSL journey. That's interesting. Yeah, I started with the book of shaders, which I really suggest just reading, even if you're not like interested in, or if you know, even if it's a lot. Like this was, I read this first and had to like sit on it for like a year before I actually could use them. But I went through the examples and I like really pushed them, and then I came back to it later. I also spent a lot of time like looking at existing examples and reverse engineering them. So for instance, like the tools, in the tools, there's the GPU particles. And like, if you just look inside of this, it's insane. You're like, what is going on? And so it took like, just kind of like examining this and poking it and then finding, oh, here's the shader, right? This is a long time ago, but this is like, oh, okay. And then hacking it basically, like figuring out how to say, okay, I've got particles. What if I want them to like home in on the mouse, right? And can I make this system do that? So those types of exercises kind of I'm at the point now where I know this whole code and I could modify it in different ways if I need to. And I often do if I need like a starter for a particle system, or I might build my own now that I know how it works. But I think just like, it's a long process for GLSL. I highly suggest it though. Cool, let's see. Do you plan on making more tutorials or starting a Patreon? Good question. I do want to make more tutorials. I plan on it. I work full time right now with Art Tech House, so it keeps me really busy. But I do want to do more, and I probably won't do a Patreon at the moment, but I've thought of it. It's sort of a, you know, committing yourself to like a specific amount of work per month. So it's just sort of personally, eventually maybe. I've definitely thought about it. Yeah. Okay. Cool. Sweet. Any other questions before we got about a minute? Oh, here we go. One other GLSL suggestion. Yeah. So maybe I can make a tutorial on that sometime. It's just a different way of thinking. Like it really, I was used to sort of even like Arduino programming, which is like very like, you've got one thing that you can always reference any part of the code, and it kind of like changes the way that you think to dive into it. But definitely like, again, going through the book of shaders, just like reading it and like trying to port that code into something like TouchDesigner to play with it. Yeah, I think it takes a long time. Like I said, it took me like at least a year of kind of banging my head against it before I started being able to use it as a tool. And even now, there's tons of like examples that go over my head very quickly in GLSL because there's so many different things that people do with it. So I'll say that. But I hope, yeah, I hope that still inspirational. Oh yeah, oh cool. I'll check out Lewis Lepton's work. Yeah, but thanks everybody. I think that's it. So I'm gonna head out.